Tips on how to approach Euclidean geometry grade 12 questions part 1. Okay, so this is the question. Okay, in this video we are going to see how to approach Euclidean geometry grade 12 questions. Okay, how can you answer questions on Euclidean geometry? Okay, so we have 5 questions to answer. Okay, you can see you are requested to find. The question says calculate with reasons the size of each of the following angles. Okay, so you have 1, 2, 3, 4, 5 questions. Okay, and you have the marks allocated. So let's get started on the next slide. Okay, this is the question that we are given. Okay, PON is the diameter of the circle centered at O. TM is a tangent to the circle at M. Okay, M is a point on the circle. R is another point on the circle such that OR is parallel to PM. NR and MN are drawn. Okay, let M1 be equal to 66 degrees. Okay, the angle M1 is 66 degrees. Now, to answer Euclidean geometry questions, always try to collect as much information as possible. Before you even attempt to answer the questions, try to collect as much information as possible. So you can see from what we are given, you have a tangent. Okay, TM is a tangent to the circle at M. So M is the point of contact. So whenever you have a tangent, what you have to think of is the tangent-chord theorem. Okay, Tan-chord theorem. You can see between the tangent and this chord. Okay, let me get a highlighter so that you can see what I mean. So let me get my highlighter. Okay. So this is a tangent TM, and you can see between this tangent and this chord, right? Chord MN. Okay, I hope you can see that. The chord MN, this chord, there is an angle between the tangent and the chord, which is equal to 66 degrees. Okay, so you can find another angle which is equal to 66 degrees. How can you find that angle? Okay, let me show you. I'm going to use my set square. You can use your hand or a piece of paper. Always try to cover this angle. Try to cover this angle along the chord. This is the chord MN. Okay, so you are going to cover the angle along the chord. Okay, you cover the angle. Now you are going to check for 2 other lines or 2 other chords which have come off from M and N. You can see you have those chords, those lines. Okay, you can see this is the first line and this is the second line. These 2 lines or these 2 chords have come off from the edge of this chord, the chord MN. From M, you have this line or this chord. From N, you have this line or this chord. Okay, so you check that you have 2 lines or 2 chords that have come off from this chord. You make sure they meet at the circumference. Okay, they have to meet at the circumference. Now, the angle between them is equal to 66 degrees. It is equal to this. Okay, so the reason is Tan-chord theorem. Okay, this is how we found this angle using Tan-chord theorem. This is the reason. You can also see that, let me erase this. Okay. You can also see that you have this angle. Okay. Let me use my highlighter. So you have this angle, which is subtended by the diameter. Okay. So this is the diameter, PON, right? PON. You can see you have this line and this line, or you have this chord and this chord that have come off from the edge of the diameter. Okay, let me show you that. I can use a different color. From P, you have this line, and from N, you have this line. Okay, so this angle is always equal to 90 degrees because this is an angle subtended by the diameter. Okay, so the angle there is equal to 90 degrees because this is an angle subtended by the diameter, or this is an angle created by the diameter, or this is an angle formed by the diameter. And the reason is angle in semicircle or angle at the circumference subtended by the diameter. The name semicircle means half of a circle. You can see you have a semicircle. You can see that. Let me show you. Can you see? Can you see that semicircle? Okay, this is the semicircle. The reason why you have the name semicircle, because everything is happening in a semicircle. Okay, you have a diameter, and then you have this angle inside this semicircle. Okay, the reason you can say angle in semicircle or angle at the circumference subtended by the diameter. Okay, now let's collect another piece of information. You can also see you have two parallel lines. Okay, PM and OR. You are told that OR is parallel to PM. Okay, OR is parallel to PM. Okay, you can see that you have this arrow, and this arrow means PM is parallel to OR. Okay, you are given that. So whenever you have parallel lines, think of the word fan. Okay, think of the word fan. Fan. Or phase, like this. Okay, fan or phase. Okay, whenever you have parallel lines, you can see you have F. Can you see this? This is F. Can you see F? So whenever you have parallel lines, you can have F or U or N. Okay, N can be Z if you rotate. Okay, fan or phase. So this angle is equal to this angle. Okay, let me show you on this. So this angle is equal to this angle. If you have F, right, this angle is equal to this angle. Make sure the two lines, this and this, they are parallel to each other. Okay, these two lines are parallel to each other. You can see this is F. Okay, F. So this angle and this angle are equal. Okay, this and this are equal. You can also have the letter U. Okay, you make sure this line is parallel to this line. So this angle plus this angle, you are going to get 180. 180 degrees. Okay, so this is U. Can you see this is U? Can you see? U. Right? This is U. So this angle plus this angle, you must have 180 degrees. When it is U, you make sure this line is parallel to this line. You can also have N or Z. Can you see that on this diagram? So N like this. This is N. Can you see? Okay. N or Z. So this line, let me use another color. This line is parallel to this line. This line is parallel to this line. So this angle, this is equal to this angle. Okay, let me use a black color. This angle is equal to this angle. Okay. Can you see? So this is equal to this. This is also 90 degrees. But we don't need this angle. Okay. So whenever you have parallel lines, think of the word fan or phase. Okay. So you can have N or Z depending on how you look at the diagram. Okay. So this line is parallel to this line. This angle is equal to this angle. This line is parallel to this line. This angle plus this angle is equal to 180 degrees. Or if you have N, this line is parallel to this line. This angle is equal to this angle. Okay, so depending on how you look at the diagram. Okay, so this angle, because this line is parallel to this line, this angle, right, this angle is also equal to 66 degrees. And the reason is corresponding angles. These are corresponding angles. Okay, corresponding angles. PM is parallel to OR. So this is how you can give the reason. Let's try to find another piece of information. You can see this is a straight line. This is a straight line. Whenever you have a straight line like this, the angle is always equal to 180 degrees. Okay, whenever you have a straight line. So when you check, the angle there is equal to 180 minus 66 degrees. This is equal to 114 degrees. You can see 114 plus 66, you're going to have 180 because of straight line. The reason is angles on a straight line. Okay, angles on a straight line. Or you can say supplementary angles. Okay, supplementary angles or angles on a straight line. This is a straight line. So angles on a straight line, they supplement. So you can give this reason or this reason. Okay, you can also see that you have this is a radius. Okay, let me use my highlighter. This is a radius and this is a radius. Okay, so you have two radii. You know that the length is the same. So this is an isosceles triangle. You know that the angle, this angle, which is opposite to this side, and this angle, which is opposite to this side, they are equal because these two angles, they are opposite equal sides. Okay, so you can say R and this angle, right? R and N1 plus N2, they are equal because they are opposite equal sides. Okay, this is an isosceles triangle. Okay, so you are going to say R is equal to n1 plus n2. Okay, this angle is equal to n1 plus n2 because the sides, they are equal, and the reason is angles opposite equal sides. Okay, this side is equal to this side. The angles opposite these sides are equal. Now we can answer the questions. Okay, now question 1 says calculate with reasons. You have to give the reasons how you calculated the angles, the size of each of the following angles. 1. P. This is the angle P. P is equal to 66 degrees. Okay, P is equal to 66 degrees. Remember, we found P by using the Tan-chord theorem. Okay, tangent-chord theorem. Okay, the reason is Tan-chord theorem or tangent-chord theorem. Now question 2, calculate with reason the size of each of the following angles. M2. This is M2. Remember, angle subtended by the diameter. Okay, or angle in semicircle. This is a semicircle. This is a semicircle. So M2 is equal to 90 degrees. The reason is angle, this is angle in semicircle. Okay, you can also say angle at the circumference subtended by a diameter. Okay, so you can give your reason like this or like this. Okay, let's carry on. Now question 3, calculate n1 with reasons. Okay, giving reasons. The question is 1 mark. This is n1. Okay, n1. The simplest way to find n1, you can see you have a triangle. Okay, let me use a highlighter so that you can see that. Okay, this is a triangle. Can you see this triangle? Okay, so you have this angle 90 degrees and you have this angle 66 degrees. You don't know this angle n1. You know that the sum of interior angles in a triangle is equal to 180 degrees. So P, angle P plus angle M, M2, okay, M2 plus N1 must be equal to 180 degrees because this is a triangle. Okay, the sum of interior angles is equal to 180 degrees for a triangle. Okay, so P is equal to 66. Okay, M2 is equal to 90 degrees, and we are looking for N1. Okay, we can find N1 easily. So the reason is sum of interior angles in triangle MNP. Okay, sum of interior angles in triangle MNP. MNP. Okay, interior meaning inside. The sum of interior angles is equal to 180 degrees. This is the reason. This is how you can give the reason. Sum of interior angles in triangle MNP. Okay, so let's carry on. P is equal to 66 degrees plus M2. This is M2, 90 degrees plus N1. This is equal to 180 degrees. So N1 is equal to 180 minus 90 minus 66. Okay, N1 is equal to, you're going to get 24 degrees. Okay, now question 4. We still have this from the previous slide. Okay, now question 4. We have to find O2. Okay, I hope you remember how we found O2. O2 is equal to 66 degrees. You are going to say O2 is equal to 66 degrees, and the reason is corresponding angles. PM is parallel to OR. Now question 5, we have to find N2. So remember, can you see? This is a radius and this is a radius. Okay, radii. And this is an isosceles triangle. Okay, angles opposite, equal side. This angle is opposite to this side. This angle is opposite to this side. Okay, angles opposite, equal side are equal. So R is equal to N1 plus N2. Okay, this angle is equal to this angle, N1 plus N2, because of an isosceles triangle. Okay, this is a radius and this is a radius. So this angle is equal to this angle. The reason is angles opposite equal sides. Okay, equal side, or angles opposite radii. Okay, this is the sum. You subtract this. Okay, now you are going to have 180 minus 66. So the reason is, let me do this. The reason is sum of interior angles in a triangle NOR. Triangle NOR. Okay, NOR. You know that the sum is equal to 180 degrees, but you subtract this so that you can have only R plus this, N1 plus N2. So now you have this. Okay, so this angle plus this angle, okay, R1 plus N1 plus N2 is equal to 114 degrees. Okay, you can also write the reason like this. Instead of writing the reason like this, you can write the reason like this. Okay, this exterior angle, exterior meaning outside, this exterior angle which is outside of this triangle is equal to the sum of the two opposite angles. Okay, now we are looking for N2. Okay, we are looking for N2. You know that R is equal to this, so we can replace R with this. Okay, so R is equal to this. This is R plus this. Okay, this is R. R is equal to this. We replace R with this because we are trying to find N2. Okay, so this is equal to 114 degrees. Now you have this and this. Okay, like terms. So this is 2 of this. Okay, 2 of this. You can see like terms. This is equal to 114 degrees. To find only N1 plus N2, you are going to divide by 2 on both sides. So N1 plus N2 is equal to 114 over 2. Okay, divide by 2 on both sides. So this is equal to 57 degrees. Now N2 is equal to, right, N2 is equal to 57 minus n1. Okay, n2 is equal to 57 minus n1. You take n1 to the right, now you have minus n1. Remember, n1 is equal to 24 degrees. This is from question 3. So n2 is equal to 57 minus 24. Okay, 57 minus 24. This is equal to 33 degrees. Okay, so this is how you can find the angles giving reasons. Okay, so alternative method. Okay, alternative method. Question 5. Calculate with reason the size of each of the following angles. N2. Okay, this is an alternative way to find N2. So this is the diagram that we are given. You can imagine that you have a chord from P to R. Okay, try to imagine that you have a chord from P to R, like this. This is a chord from P to R. Now, you have this angle at the center, which is subtended by this chord. Okay, let me use a highlighter so that you understand what I'm talking about. Okay, so you can try to imagine that you have a chord from P to R. Okay, now you have this angle at the center, which is subtended by this chord or this arc. Can you see this arc? Okay, the angle at the center subtended by this chord or this arc. Okay, so now, so the angle, this angle O1, which is subtended by this chord, the chord PR, or this arc, the arc PR, is this angle at the center. This is the center, okay? The center. This is twice this angle at the circumference. Okay, the angle subtended by the same chord. Okay, the angle subtended by the same chord now at the circumference. You can see the same chord. You can see, let me show you. By the same chord, you have this, the same chord, this angle, N1 plus N2. Okay, from the same chord. Or from the same chord, you have this angle at the center, and using the same chord, you have this angle at the circumference. Okay, let me clean this. So the angle at the center of a circle is twice the angle at circumference if the angles are subtended by the same chord or by the same arc. Okay, so this angle was 66 degrees. Okay, remember from the previous slide. Okay, now this is going to be 114 degrees because of straight line. Angles on a straight line supplement. These are supplementary angles. Now, the angle subtended at the circumference is going to be half of this, which is 57 degrees. So, O1 is equal to twice N1 plus N2. Okay, 2 times N1 plus N2. This is what you are told here. Okay, the angle at the center is twice the angle at the circumference if the angles are subtended by the same chord. Okay, you can see the same chord PR subtending this angle, the same chord PR subtending this angle. This is what you have to remember. Okay, so the reason is angle at center is twice angle at circumference. Okay? Angle at center is twice angle at circumference. This is the reason for writing this. Okay, so we carry on. Now, O1 is equal to 180 degrees minus 66 degrees. This is 114 degrees. So the reason is angles on a straight line. Okay, I can close this for now. N1 plus N2 is equal to 57 degrees. Now, N2 is equal to 57 degrees minus N1. You take N1 to the right. Now you have minus N1. And N1 is equal to 24 degrees. Okay? From question 3, you can see that. Now, N2 is equal to 57 minus 24, which is 33 degrees. So this is an alternative method that you can use to find N2. Okay, more videos are coming. For now, we are done. Until next time, I will talk to you soon.